Alright, this is a dry run for the React Advanced work, well, talk. Hi everyone, I'm Sean, and let's talk about reactive hooks from scratch. I'm Sean, I work in Netlify, I help to moderate the r/React.js subreddit, where we're very excited about hooks and concurrent React. And I'm a big proponent of learning in public, which is what I'm doing here. I'm sharing things that I'm learning that I think are cool, and I think that um, that's the best way to learn anything. But I have to confess to you something. I have a problem. When I signed up for this talk, I was very excited about reintroducing hooks to everyone here. In fact, I'm supposed to tell you what hooks are. I'm supposed to tell you about the rules of hooks. I'm supposed to tell you about the problems with closures that people have when people deal with hooks. I'm supposed to tell you what closures are, and I'm supposed to help write hooks from scratch. And then I'm supposed to end up with uh, with a 29-line hooks clone, a React 29-line clone of React with hooks, where you can actually write a standard component with custom hooks and actually see them interact with an API and dynamically update. That's what I'm supposed to do. The problem is, I've already given this talk. I gave it 3 months ago, and I didn't have anything else back then, so I resubmitted it for this conference. But the thing is, you can check out this talk on your own. I think all of you are very familiar with hooks. And with the release of React Suspense and Concurrent React yesterday, I think our collective minds are sort of more wrapped up around what is this whole concurrent React thing. So, with your permission, I'm going to give a different talk today. Is everyone okay with that? So, I'm going to do concurrent React from scratch. And that's a way more ambitious talk that I am completely not qualified to give, but I've had a lot of help from some people. And if I get anything wrong, let's talk about it. Let's learn together. So, what's the agenda today? We're going to talk about what React Fiber is, like what it really is. A lot of people know that it was a rewrite, it was a project, but they don't really know the data structure. We'll talk about rendering. We'll talk about what React has to do with linked list traversals. We'll talk about the difference between reconciliation and committing. We'll talk about adding a use state hook and how the work loop works together with updating anything in React. We'll talk about time slicing and how that impacts the work loop. And then we'll add suspense because why not? So, a lot to do in 30 minutes. Let's get started. First, I want to acknowledge a lot of this code and inspiration comes from people who have figured it out before me, primarily Rodrigo Pombo with his Didact project. And it's called Build Your Own React. I highly recommend checking this out. Um, but also resources and also the React Fiber architecture gist from Andrew Clark and the React Fiber talk from Lynn Clark. Okay, let's talk about JSX elements because that's what we're familiar with. JSX elements are plain old JavaScript objects. They specify type and props, and that's it. So this is an example of type and props, and that is analogous to React Fiber, which has type and props, and then a whole bunch of other stuff, including the DOM elements, the linked list, and then the links to a bunch of other fibers. So the child fiber, the sibling fiber, the parent fiber, and the alternate in case, which we'll talk about in a second, as well as hooks and any effects that are being placed on it. So let's write React Fiber. And now this is where we start to go to live coding. And here you'll see that I have a blank index.js. It only has a CSS file with a nice animated background, but apart from that, this is all I'm running. I'm not running any code right now. So I'm going to start by copying in the imports that I'm going to initialize. So I should also explain up front that I have a utils folder, and it just is 100 lines of code, basically scaffolding out like things like create element, how to update the DOM, and how to reconcile children. All of these are pure functions, and we'll talk about how to handle those, and we'll see them in use, but not a whole ton of magic here in importing the utils folder. I'm also going to place a lot of pointers on the global scope, as well as declare React dot create element so that we can use JSX. All right, so now let's write our first fiber. Again, I'm going to paste it out. So here I'm going to say my work in process root fiber contains the DOM and props. I don't need the type. I don't need a type because it's the work in process, because it's the root fiber, but I will need it for everything else below it. And then I'll specify the DOM as well as the props, where the first child is just the element being an h1 of hello world. And you'll see that this is the same thing as just the just this guy right here. Yeah. All right, fantastic. Um, so that's it. That's our first fiber, and now we'll talk about how to render it. So right now, and now we'll talk about how to render it. So let's actually take this h1 hello world thing and let's actually try to render it. I have a simple render function saved as well. And this is going to take the element and the container. It's going to create the relevant nodes for all the uh, relevant DOM nodes for each element. And then it's just going to append child onto the container. And that's where we see hello world printed out over here. That's fantastic, but it doesn't really scale, and now I'm going to have to explain why it doesn't really scale very well. So this is an example app structure with a div, an h1, a ul, and lis. And so I want to sort of break it down visually to see what's going on and what's the work that needs to be done. So with the rendering that we did, and that sort of recursive, what we're basically doing is we're doing work and then we're committing to the DOM at each time. So I'm handling the div, I commit to the DOM. I'm handling the h1, I commit to the DOM. I handle the UL, I commit to the DOM. And each time, there's an opportunity for me as the user to actually look at the DOM and see things in a half updated state. So this is state tearing, where I've updated the DOM for some pieces, but not all of them. And you can see an inconsistent state. And this causes anything from layout thrashing to just a really bad user experience in general. So this is what we want to avoid, but unfortunately this is the formula that we have when we do work and commit the work at the same time. So that's rendering. What about reconciliation? So let's talk about the uh, reconciliation of fibers. First, I'm going to assume that I'm going to start from a work in process root fiber. I'm also going to say I'm also going to split up the work that I do from committing to the actual DOM element. So I'm just going to call it perform unit of. I'm just going to call this work perform unit of work. I'm going to chunk it up so that I can perform this work um, element by element. So here I'm performing the work on the div, then I perform it on the h1, which is the first child of the div, and then I perform, and that H1 has no children, so I'm going to perform it on the sibling of that H1. At this time, the user comes in and has a look. Nothing's changed because nothing's been committed. All this work is being done on the fiber uh, instead of uh, the actual DOM. So that's great. Let's keep going. We're doing work on the first child. Always do work on the first child if possible. And if there's no children, I'm going to do it on this sibling. There's no children, no siblings. So I'm going to just return up to the parents and head on up back to the work in process root. So at this time, when once I realize that I've reached back to the root, then I know that all the reconciliation in the entire tree is done. And by the way, what's the big O of this operation? It's O of n, which is very nice. Modern DOM diffing methods are something like a proper DOM diffing method is O of n to the power of 3, and so this is a lot more performant because we assume that if anything's dirty, we re-render everything. So this is a lot more performant. Anyway, so now everything is completely reconciled. We have a new set of fibers for each one of these things. And so now we're just going to commit all of these fibers at once to the current root. In reality, React actually just commits the updated fibers, but here but in our implementation, we're just going to commit everything. And the user gets to see a very nice transition from the previous state to the post state without any tearing, and that's the guarantee that React offers. Um, if you want to learn more about traversal, there's a very nice issue that I recommend where Sebastian from the React team actually talks about the principles between the high level concepts about fiber traversal, which is basically what we've covered here. All right, so let's actually implement the reconciliation, and basically what we're going to realize is that this is reconciling children, and then this is committing it to the DOM. So we're going to replace all this code, all this render code, and we're going to replace it with a more complicated but actually more accurate setup where we're just going to say we'll have a unit of work, which is we start at the root, and then we'll perform a unit of work, and we'll traverse through the tree like we talked about, and we'll reconcile children at every step of the way. And while there is the work to be done, we're just going to keep looping. And once we're done looping, we'll then commit the work. Commit work here is a function that simply just updates the DOM or appends children or deletes children. And that's literally all we're doing over here. So again, this is working code because our element is rendering. But now we have a very nice separation between the reconciliation phase and the commit phase. All right, so now let's add a hook. So we're going to add the useState hook, which is the sort of basic hook of every component. Again, we're going to paste it in because I don't trust myself to type all of this stuff. Notice the really awesome operator I'm using over here. Anyone know what that is? Yep, that's right. And so useState basically says, it makes use of the hooks field on a fiber. And we're basically saying that, and we're basically taking advantage of the hook position in order to know which hook we're accessing. And that's a very key part of the design of React hooks. But also notice that when we set state, we're actually not really scheduling, we're actually not really calling anything. We're just setting a bunch of globals. And in particular, we're setting the work in process root fiber um, and to just start again to reconcile from the current root. And that's not as optimal as it could be, but we're just going for a very rough clone right now. And then we'll say that all right, now we have the next unit of work. It's no longer null, so therefore get to work reconciling these things. All right, so let's expose useState onto the React module that I have over here, and now I can have a little demo of useState. Not over here. Okay, I can have a little demo of useState down here. All right, so now I have a clicker, and that's my current demo right now. It's just a button where I can click it. Unfortunately, when I click the clicker, when I click the counter, it doesn't work. And why is that? Well, that's because we haven't really set up any process to restart this. Like basically, we run this reconciliation and committing loop once, and then we never run it again. So in other words, we actually need to loop this and wrap this inside of a work loop, and that's exactly what it's called. So now I'm going to get rid of this code, and I'm going to put in a work loop that is going to look very similar, but it has a certain recursion around it that basically makes sure that it's always running. All right, so now I have a work loop. It basically relies on request idle callback, which is a DOM API, and it's just running. And if there's work to be done, it's going to call that next unit of work. And once there's no more work to be done, it's going to commit that work to the DOM. So exactly like what we did before, except that now it's looping back on itself um, every single idle callback. So now when I click the button, it's going to update properly with a click, and so that's very good. And so now we have a working uh, work loop. We're also going to implement time slicing a little bit. Here I'm just going to hand code it a little bit because it's not that hard. So the problem with this work loop is that it's just processing one unit of work after one unit of work after one unit of work. And so if you have a lot of work chained up after the other, it's basically just not going to slice. It's just basically going to choke the code. So essentially what you want to do is you want to have a way to detect whether the work loop should yield to the broader process. And so I'm going to start it off with false. And so basically, while the and basically I'm going to say that should yield should be true if deadline dot time remaining is less than 1, and we should yield it whenever, and we should say we should only run this loop if should yield is false. There we go. So that's time slicing, because basically whenever there's no more time left in the deadline for the request idle callback loop, then we'll just not run the next unit of work, and then we'll just wait till the next idle callback to continue running the next unit of work. And that's why we run it in such a weird way, to basically chunk up the units of work so that we don't have to finish everything in one go. Okay, so now we have time slicing. We're also going to talk about creating root. The the way that I declare my root over here, and then I stick the element. So the way that I declare my root over here, and I stick the element, I manually stick the element onto here. It's not very nice. I think it definitely, isn't it's definitely not the API that we use with React. So I'm going to get rid of that, and I'm going to actually have a nice render function. Um, so I could have a render function, or I could have, um, I'll have a nice render function. All right, so this is still working, and it's just filling out some on the more basic things that we have over here, which is great. But we might as well use create root because that's the API that we have right now, right? So I'm going to say create root. Create root takes the container and returns the render function, which takes an element. And then we can just move all this stuff inside. All right. So now we can say create root container dot render element, and that should do it. Wonderful. So now we have replicated the create root API. I can also go ahead and stick it on to the React module over here. So yeah, that's a lot of the API already done. And in fact, we can clean this up a lot by moving it out to a separate module. Guess what I'm going to call that module? I'm going to call that module React.js. And my computer is choking right now. And I'm going to just copy and paste a whole bunch of stuff. Actually, I'm just going to copy and paste everything. Um, so I'm cutting all of this stuff from the index.js that we wrote. I'm pasting it into React.js. And I'm saying I'm going to export React. I'm also going to get rid of the app over here. All right, so now let's try to have a very basic all right, let's try to have a very basic app in here. So we're going to say import React from React. Good. So now we have a working React clone. And let's actually try to make an app that does what it's supposed to do. So I think I have one pre-saved over here. I never did. Huh. Oh, I should probably do that. All right, so we're gonna have an app. And And let's try to make a small little app right now. App on state set state goes to actually fuck it. I have a demo over here. Yeah, that works. Okay, I have back my working app, which is very nice. All right, so the last section I'm going to do is adding suspense because that's the hot new thing, right? That came out. So if you look at the docs for suspense, they'll say talk about what is suspense exactly, and they have a nice little demo. I assume because this is React Advanced that y'all have a rough idea of how suspense works under the hood. Basically, it throws a promise, and the exact way it does it is implementation details, but because we're cloning things, that's exactly what we care about. We care about implementation details. Um, and if you already played with the suspense demo, you'd be quite familiar with this. And notice how they always say in the mock API, don't copy paste this into your project. Yeah, we're gonna copy paste to the project. So we're gonna go to fake API. We'll copy paste. Actually, I'm gonna copy paste a small variant of that. Fake API with more users. And I'm going to head over to index and I will pull in the same, and I'll pull in the sample app. So I'll pull in a fake API app over here. And so now it's fetching that data, but it's going to start throwing errors. Oh, look at that. This app is not defined. It's going to start trying to fetch the data, but because we have no way to catch all these throws that are being held inside of the resource reads, that's an issue for us, right? So what we're basically going to have to do is we're going to have to go inside of our work loop and try and catch those errors as they happen. So over here, the errors will happen as we perform unit of work. So in real React, we'll have a suspense component to do this, to tell us whether we're inside of a suspense component. Here, we're just going to implement it for all of React. So I'm going to add a try catch over here and put the unit of work inside, and I'll catch it. I'll catch the error. If what's being thrown is a promise, so if error instance of promise, I'm going to handle it. If not, I'm going to throw error because that's just not something I should handle. So over here, if it's a promise, I should just call it and call that then, and do something with that. So what I'm going to do over here is I'm going to try and freeze that set of work. So I'm going to say, for example, let suspended work equals next unit of work, and then we'll say something like, all right, if it's a promise, then we're going to suspend, right? Suspended work equals to null. Then we'll say suspended work equals to next unit of work. So we'll suspend the current piece of work that we're working on, and then we'll set our next unit of work to 0 so that we'll stop trying to re-render this thing on and on again. And only when it's refreshed, then we'll unsuspend it with next unit of work equals to suspended work. And then we also must not forget to reset the work in progress root finder to the current root. All right, so that's a little bit of mumbo jumbo, but we've just wrapped a try catch around of our project, and now we should be able to fetch data accordingly. What am I doing wrong, motherfucker? Don't call the error. Don't go chasing waterfalls. You don't have to feel that you used to. I don't have to go around you always on nothing at all. I just wanna be. Don't go chasing waterfalls. I just wanna you to really used to. Running off you know on nothing at all. My mama told me a long day. I little child. Just move ahead, baby, you'll go. My computer's died, okay. Ours died, okay. My computer's dying, okay. And it's dying, okay. I tried, baby, I was born this way. Alright, assume that that worked. I'm just gonna close it out. Alright, so what have we learned today? That we can implement suspense. We've also learned what fibers are, how to traverse them, what reconciliation is, use state, time slicing. What's missing? There's a whole bunch more. DevTools, fragments, priorities, server-side rendering, error boundaries. All these are very important, and we didn't implement any one of those, especially the two neo hooks use deferred value and use transition. So definitely, and that's an exercise for the reader. Thank you very much.